Okay, today we talk about the fundamental of electric circuit. This is chapter 2 of our reference books. Okay, uh, so the objective of the learning objective is to identify the principal element of electric circuit: node, loop, range, voltage, current source. Okay, we try to refresh again. What is node? What is place? And what is the branch of the circuit? And uh, what about the source in our circuit? So we have two types of source, which are the voltage source and current source. So we will talk about the Kirchhoff laws. We have two Kirchhoff laws, which are Kirchhoff current laws and Kirchhoff voltage law. So we will apply the Kirchhoff law to solve the circuit. Okay? And then we will talk about the sign convention. So this is to represent the direction of current and voltage by the positive sign or negative sign. Flow this way is positive sign. In the opposite direction, we can represent the current in opposite direction by using negative sign, right? Okay, just make the same understanding, okay? When we talk about the circuit, okay? And then the basic voltage and current divider laws. Okay. After that, we may have some time to talk about the measuring instrument and the example, right? The application of the circuit, right? For measuring device, so such as the stand gauge, with the voltage and current and power. Okay, firstly, we talk about what is branch, node, loop, and mesh. Okay, and the ideal source, which are voltage source and current source. This is the ideal source. Ideal source is mean the source that can supply the exactly voltage or current we specify, right? But it's not in the real world, right? In the real world, when we use the voltage source, sometimes the voltage is dropped from the specified current. Okay, for example. Okay, the ideal voltage source provides a prescribed voltage that is exactly the value that we specify. Okay. And irrespective of the current flow through it. Okay, this is the ideal voltage source. We can have DC source, or we can use this symbol like a battery, or we can use the AC source symbol for represent the AC source. And the AC source usually in the form of sinusoid, cosine or sine, cosine and sine function like this. This is this AC source, and this is the DC source, and the voltage is just always constant, right? For ideal voltage source, okay. In our calculation, we assume it's constant, but it's not in the real world. Okay, right? When you use the battery, when you load the battery much, the voltage drop. Okay. And this is the various representation of electrical system. We can have source, we can have load. We can draw like this. This is the source side and load side, or we can draw in the form of the symbol of voltage source to the load, right? Or you can present in the shape of battery with the lamp, for example. And this is the this source represent more practical source. The more practical source will have internal resistance, right? internal resistance. So this is when you represent, for example, if you represent this battery with the ideal source, this is positive, this is like this positive pole and negative pole. This is ideal. But more practical representation, it will have internal resistance for positive and negative. This is for this battery. This is for this battery. This is practical, right? We have the internal resistance for this type of source. Okay. And this can heat up also because it's the resistance representation. This type of cell can heat up when you load the current. Okay. And this is a generator, right? Usually generator provide the AC sinusoidal voltage. And this is a very large generator. This is also AC source. And this is maybe 3-phase AC system. So we can have a 3-phase AC system. Okay. This is the type of current source. Okay, we can have current source also in the laboratory, but it's not often that we find in the daily life. Okay, in our daily life we don't face current source. Besides current power supply, right? Power supply or the battery charger. This is the battery charger. Because sometimes we charge the battery, we need constant current, right? Yeah. When we charge the battery, so we transform AC system to DC system, right? To DC system and charge our battery. This function, we need to control this system for constant voltage or constant current. To manage our battery state of charge, okay? Sometimes constant voltage, sometimes constant current. So we sometimes need to solve the circuit with constant current. Okay. So the ideal current source that also provide the prescribed current exactly the current that we specify in the circuit. Okay. So this is the ideal circuit. For practical current source, maybe like this. This is practical current source. And this is the dependent source or controlled source. This is a source that depending on some other parameter in the circuit. Okay. Like voltage, control voltage source. This means we can control this source by some voltage somewhere in the circuit that we use to control the source. Right? This is maybe Vx, right? If we verify Vx, Vs will change it according to Vx. We change Vx and Vs will change in according to Vx. Okay, Vs, the source, the voltage of the source will change in according to some other external voltage. So we can control Vs by Vx. So this kind of source will maybe in the electronic circuit, right? When we adjust the small voltage, that the larger voltage is changed, okay, to control some equipment, okay, to control some equipment. Or we can control the current source by voltage. Oh, sorry. We can control the voltage source by current. We call current control voltage source, okay, CCVS. So this current, if the current Ix changes, Vs will be changed in according to Ix, okay. So we call current control voltage source. And we can have the current source that's depending on voltage or depending on current, which are the voltage control current source. This is the current source that controlled by the voltage. Okay, if we change Vx, Is will be changed. And we can have current control current source. So we change current, the current Is will be changed, okay, for some circuit. Okay. So the control source or dependent source will be in this shape, okay, in this symbol, voltage and current. And when it appears in the circuit, it makes the circuit more complex to solve, okay. Complex to solve. For example, if we have Vs connected to some circuit like this. This is a common circuit, but if we change Vs to dependent source, this, for example, Vs may be V4, Vs equal to 5 times of V4, for example. Whatever V4, Vs will be changed according to V4. So this circuit is more complex to solve, right? Okay. But we don't touch much about the control source. Okay. Okay. Now we talk about what is branch in the circuit. Okay. The branch can be combined with any equipment like resistance or source or maybe an ammeter, like this, the branch. Okay, we call the branch. For example, this is the branch, this is the branch, right? And we can have node, right? The node is the connecting point between the branch. So one connect together, we call that point is the node. Right? It's the node of the circuit. Okay. And we can also have supernode. Like this, if we call this is one node together. And the current flows through this node. We can also apply the KCL. Right? The current flow in and out can be use the theory of KCL as well. Okay, there's a node in the practical circuit, right? It's the connecting point of the branch. This is a node, right? Here. So, right? In the circuit, this also we can have node. So, connecting to the same point, right? This, right? This, right? The junction, right, of the circuit. And this is a node in the circuit. Okay. And we can also define the loop in the circuit. So the loop is any closest connection of branch, any closed path. So the circuit can work only they have the closed path is access, right? The open circuit will not operate, right? The current cannot flow, right? So the circuit can work only when there is a closed circuit. So the loop is any closest connection. This means that, for example, in this circuit, we can have 3 loops, right? Loop 1, loop 2, and loop 3, right? We can have 3. Okay? And this we have only 1 loop. This circuit we have 3 loops, right? Okay. And how about this circuit? So if I draw this circuit, how many loops is there? Four loops. 1, 2, 3, right? 4, 5, right? So many loops, right? 6, 7, right? Okay. So we can have many loops. We can define many loops in the circuit, right? Any closed path, right? Any closed path in the circuit. Okay. But for the mesh is the loop that not contain any other loop. Yeah, cannot. Loop 3 contain loop 1 and 2, right? But for the mesh, it's not contain any other loop. So the mesh is what exactly specified. Right? For example, this circuit we have mesh 1, 2, 3, 4. We have only 4 mesh, but we have many loops, right? If we define the loop, we will have many loops, right? The mesh, and we will use the mesh. We will use the mesh to solve KVL. Right? So the mesh is a type of loop. So sometimes we call mesh as a loop. Okay, mesh is a type of loop, right? So we can call this loop 1 also. Okay, but mesh is more specified, right? Just more specified word. Okay. So if we would like to count the loop of this circuit, you will get 15. Okay. This also, right? This also, so you can get 15. Okay, but this circuit we have only 4 mesh. Okay, so I skip charge and current and we talk about the Kirchhoff laws. Okay, firstly, the Kirchhoff current laws. Right? It's a well-known theory for solving the circuit. It's KCL, Kirchhoff current laws. Right? Okay. So this law states that the charge cannot be created but must be conserved So the sum of current at a node must equal to 0. The sum of current at the node must equal to 0. So the sum of current is mean I should equal to I1 plus I2 plus I3. So this is have 4 part, right? I and I1 to 1 to T flow. Right? Or if we specify the current with the sign, right? The current flowing in is negative, flowing out is positive, flowing out is positive, So we can use this equation, right? So the sum of current at the node is 0. Here. So Kirchhoff law states that the sum of current at the node is 0, right? But we need to specify the correct direction, right? By positive and negative sign. Okay? By positive and negative sign, we use this formula. The summation of current is 0. This is example if we have to supply the current to many parts of our system. For example, the car electric system, we have the current from battery is will equal to the current supply to all the parts, right? If you turn on the headlamp, tells the fan and the lock, and this is the current used in all equipment is equal to the current from the battery, right? So this can be explained by KCL, right? Kirchhoff current law. Okay. This is very common calculation, right? Okay. Okay. Let's try to use this theory, right? So if we have this circuit, if we know some quantity, Is, if we know Is is 5 amp. So if we know Is is 5 amp, and I1 is 2 amp, and then I2 is minus 3 amp. What mean by this value? It means that in fact the current flow into node A 3 amp, right? So we can represent I2 with this direction by negative sign. Okay. And I3 is 1.5 amp. Okay. So how much for I0 and I4? Simple, right? This is then I4 plus I1 plus I2 should be 0, right? Then we substitute I1 and I3, we get I0, but I0. To get I0, let's apply this equation, right? We apply KCL at node A. At node A. KCL. Then now we apply KCL as node B. In fact, the full formula we need to use this, like I see at node B. I0 plus I1 plus I2 plus IS plus IS. If flowing in is positive, flowing out is negative. Flowing out is negative, right? Yeah. So minus I3 minus I4. Yes. But we already know that this the sum of the three current is 0, right? So we can we can write down only IS minus I3 minus I4 is 0, like this, right? Because we know already that the upper part sum is 0, so the sum of lower parts is 0. We substitute IS, I3, and we get I4 at 3.5. Okay. Yeah. Okay. So we need to careful about the direction. Okay. If I4, if we represent I4 with this direction, we get 3.5. In case if we represent I4 with this direction, what happened? So our equation will be IS minus I3, since I3 is flowing out, and then I4, if we assume I4 flowing in the node, so we plus I4 here equal to 0. So IS is 5 minus 1.5 plus I4 equal to 0. With this equation, we get I4 at minus 3.5 amp. Okay. In fact, this is the same answer, right? But we assume I4 flowing in the node, right? But we don't know what is I4 before we solve the circuit, right? Okay. But in this case, the problem specified for us, right? It's flowing out, so we get 3.5 amp. Okay. Still not too hard, right? So we can go fast, right? Not too fast, I think, because this is. Or we can use KCL to the supernode as well. To the supernode as well. With this circuit, we know I3 is 2 ampere. I3 is 2 ampere, right? This is 2 ampere. And I5 is 0, so no current flow here. Okay. Then we can formulate the problem. IS1, I3 and I5, right? If the current flow into the node is positive, then flow out is negative and negative. So our formula will be IS1 minus I3 minus I5 is 0, right? Yeah, right. So IS1 minus I3, so minus 2, and minus I5 minus 0 equal to 0. So IS1 is 2 amp here. So we can solve for IS1, right? Okay, then now we talk about the Kirchhoff voltage laws. The Kirchhoff voltage law states that the net voltage around a closed circuit is 0. So the sum of voltage around the circuit is 0. Right? So sigma V n is 0. So if we have any circuit, V1, V2, V3, V4, there's a voltage across, right? is 124. The voltage, summation of voltage across the circuit is 0. So it's V1 plus V2 plus V3 plus V4 equal to 0. But we need to be careful about the direction of voltage also. Like this. So there is two types of equipment. The equipment that supply the energy and the equipment that absorb the energy. And when the current flow from the source, it will flow out the positive pole, okay, the positive polarity. But when the current flow into the equipment that absorb energy, dissipate energy, the current flow into the positive, okay, the positive polarity, okay, positive polarity, like this. So if V1 plus V2 equal to 0, like this, this means that V1 will be positive, flowing out from positive. So V1 is plus 1.5 volt, and in this case the current flowing out from negative. So V2 will be in negative sign, 0. This means that V2, the voltage across this lamp is 1.5 volt, right? For example, to apply the KVL. Yeah. Or for convenience, we can assign some value as reference node. For example, this circuit, we use node B as the reference voltage. This node B is 0. The current here is 1.5, right? Respect to node B here. And V2 also VA minus VB also. So it's equal. V1 and V2 is equal in this case. Okay. So to make a reference is similar to that we have a physical reference ground, and the voltage representing comparing to the reference node, right? The voltage comparing to the reference node here. And in many cases, we solve the circuit by use one reference node. Okay, one reference node. We write down this symbol, or maybe we don't need to write this symbol, but just to keep in mind that this node is reference. Ground node. So the voltage comparing to this node is the same way with the potential energy comparing to our reference, okay, reference ground. Okay. This is an example of the Kirchhoff voltage law. When we connect the battery in series, positive to negative, positive to negative, positive to negative, the voltage of the battery will increase, right? Increase. If you have 12 battery together for 13 pack of battery, so the total voltage would be the 13 pack of battery multiplied with 12 is 372 battery packs in this case. This is the battery in the electric car. Yeah. Battery in electric car. So we can scale up the voltage of the battery by series connection, right? Series. So like this, when we apply KVL, the positive value of battery 1 plus positive plus positive plus positive equal to the voltage of the load. And then the summation of battery voltage equal to the voltage of the drive. Okay. The drive, that is mean that the voltage of the power converter to the motor. Right? Okay, before talk about this example, right? I just to make some understanding about KVL. So if we have the voltage source, we have the voltage source like this. This is the voltage source V. V1, V2, V3, V4. So we specify the polarity of the equipment. For the source, the current will flow out. Remember that for the source, the current will flow out from the positive side. Okay. And for the load, right? For example, this is R1, this is R2. For the load, the current will flow into this positive polarity. And for the source, this is the same. And this is positive polarity, plus, minus. Then we apply KVL. Okay. We need to do it systematically, right? For if the current flow out from positive, we use the voltage positive. Flow out from negative, flow out from positive, flow out from negative. Okay. Our equation would be V1. V1 is positive, but V3 will be represented in negative form. Right? Because the current is flowing out from its negative polarity. And then how about V2? V2 is positive V2, like this. And for V4, the voltage across R2, V4 is negative V4, it will be 0. Okay? To solve this circuit with KVL, so we can get this equation. So for source, current flow out from positive source, and for the load, the current flow into positive, right? Like this. This for source, and this for load. So we need to specify the polarity of the voltage across the load. Okay. By assuming the direction of current first. Okay, let's see this example, right? To apply KVL. Okay, with this circuit, we know that Vs2 is 12 volt, V1 is 6 volt, V1 is could be resistor. V3 is 1 volt, this could be resistor. Then what about V2, right? What about V2? So we use KCL with this KVL, KVL. So how to specify the sign of the voltage, right? For Vs2, the current flow out from positive, V1 from negative, V2 from negative, V3 from negative. So we get this equation, right? So Vs2 minus Vs1 minus Vs2 minus V1 minus V2 minus V3 is 0. So we substitute Vs, V1 and V3. We get V2 at 5 volt, right? We get V3 at 5 volt. It means that the voltage from the voltage of the source equal to the summation of voltage of the load, right? 6 plus 5 plus 1 is 12. Okay, the summation. Okay, another example. So from this circuit, determine the unknown voltage V1 and V4. If we know that Vs is 12, Vs2 is minus 4, Vs2 is minus 4. What mean by minus 4? It means in fact Vs2 is in this direction, right? Like this, right? But the symbol draw with this direction and with negative sign. V2 is 2 volt, 2 volt. V3 is 6 volt. V5 is 12. So to find out V1 and V4. Okay. V1 and V4. So first we define this loop first. KVL with this loop. For KVL with this loop, we get that Vs1 positive minus V1 minus V2 and minus V3, right, is 0. Also, we can draw this loop. How about this loop? This loop, with this loop, V2 become positive. V2 is positive, right? and Vs is negative, and V4 is positive. So we get this equation, right? Okay. Just follow the system, the systematic of the sign. Then we can also have loop number 3. Image number 3 with this. Okay, like this. Okay. So with this loop, V3 is positive, right? Vt is positive, but V4 is negative and V5 is negative. Then we have this equation. Okay. This equation. Then we substitute the value, right? We know Vs1, we know Vs1, we know V2, and we know V3. With this equation, we get V1 at 4 volt, right? Now, V1 is solved. Okay. How about V4? Maybe from this equation, because we know V2 and Vs, right? V2 is 2 volt. V2 is 2 volt. Vs2 is minus 4. Then we get V4 as minus 4 volt, right? V4 as minus 4 volt. So V5 is 12. V4 is minus 4 volt. This means that for this equipment, if we assign positive value and negative value for V4, we will get a value of minus 4 volt. This means that in fact it's 4 volt with this polarity, right? V4 is with the reverse polarity is positive 4 volt. Oh, no, 6, right? 6 volt, sorry. V4 is negative 6, right? Sorry, negative 6 volt. If we represent in the reverse polarity, we can say 6 volt, right? With this polarity. Okay. Then we already talked about KCL and KVL, and it's not so complex, but we need to keep following the systematic, right, arrangement. Otherwise, we get confused, right? We get confused when we formulate the equation, right? Okay, just follow the step, right? We don't need to think too much about how to solve, right? Just follow the step, right? To keep the loop systematically, to keep the node systematically, right? The method is already, someone already made the system for us to follow, right? At this moment, right? Okay, if you keep familiar with the circuit, so maybe you can adjust maybe your self convenient method later. Okay, but this is moment to keep the systematic first, right? After you have some skill, maybe you can solve faster, right? This is faster. Okay, but when you get more skill, you don't need to follow the step. Okay. An equation. go to the next section. So you need any break,
Yeah.
right? So we take 5 minute break.